All right, folks, welcome. Clocking in because we're going to have a pretty packed agenda here today. Mostly because this is probably two of my most favorite topics, generally in computer science, I would say. Maybe a little bit relative to Python as well. What is the agenda today? We're going to finish up the last two sections of chapter 10. I touched briefly on multiple inheritance, so we'll look at that real quick. And then we're going to do unit testing. I'll spend a pretty good chunk on that. That's the part that I'm really, really passionate about. And then we'll get into chapter 11, which is exceptions, which we've already seen exceptions, but now we're going to go into a little bit more detail. Hopefully, we'll finish off most of that chapter. We might have a smidge left over for Monday. And Monday, we'll get into our last and final chapter, which is on modules, which we've already been introduced. We use the random module, the math module, that stuff. So just a little bit more detail on that. All right. So by way of recap, and this is what you need to know for assignment 10, because you will be writing UML. Remember, this is the way we communicate, maybe to a degree, to the people who aren't programmers, who aren't computer science majors. You don't really have to know code to understand this. You just have to understand the concepts. The concept is the class. These are the attributes, and these are the methods. There was a question asked about the assignment. When you have the methods, are you supposed to put like the name of the parameter or the type? And for this purpose, it's really up to you. But I think it's preferable to do the type. So if you were going to have a method called getPrices, let's say it took a parameter called with tax, without tax, you might want to let people know you're expecting a Boolean or the number 1 or the number 0, something like that. So it might be, it's more intuitive to say getPrices with int, something like that. And then later on, the documentation can say what that parameter is. But it's difficult in Python because it's not a strongly typed language. You could say getPrices takes an int. You could say a string takes whatever. And Python will let you pass in whatever you want. It's just inside your implementation, unless you're doing an is instance of check, it might not make any difference. All right, then we started looking at how those classes interrelate with each other. And the first two relations we talked about were the has-a relationship. And I refined that a little bit. I'm just more interested that you retain the has-a concept. So a menu has menu items, a restaurant has menu item, has menus. The difference is a menu item, its name even tells you, it really can't exist in a vacuum without the concept of a menu, right? So there we would sort of say that that's a composition. A menu is composed of menu items. Versus aggregation, a restaurant has menus. Menus can exist without a restaurant. A restaurant has a lot of other features besides the menu. But as long as you know the has-a is different than is-a. So these derived classes, this is what most of chapter 10 was about, inheritance. So breakfast menu inherits from menu. Lunch menu inherits from menu. In the lab, we looked at the base class instrument, and then we had the subclass string instrument. They could have reasonably did percussions. They could have done woodwinds. Those could have been reasonable subclasses of instruments as well. Reminder, if you get stuck on how to draw this stuff, there's a video out in Blackboard. So those derived classes, we had to remember this, and I think we got enough practice in lab yesterday, but there's two tricks to this. When you have your derived class, so I have my gamer persona here, I say parentheses and the name of my parent class. So we assume all gamers are people. This line here, we had to explicitly call the constructor of our person to pass in these details, right? There was a question I was talking to somebody about earlier today that was like, hey, why does this gamer person have to take dish when it's already up here on person? Well, it's because there's no magic. When you construct your gamer, you have to sort of pass that information up here. And we saw when we went through the Python tutor, the flow of control goes in when we call the constructor, goes from here into this constructor, it stores off the dish, not games. Games is just stored down here. So if you find yourself with a parent class that has attributes, you should not be storing them as instance attributes down here. That's the job of your parent. Your parent should be storing all that stuff. Then we got into this concept of the mixin, where we said, okay, we all agree there's a concept called coffee machine, and then there could be a latte machine and an espresso machine, and those might require some special behaviors or some special attributes. And so in Python, they use the suffix mixin. I really hate it, but it is what it is. For the most part, it's usually just the implementation of methods, but you can put other attributes on there if you wanted to. Most languages are not going to allow you to have multiple inheritance. So don't get too comfortable with that. As soon as you move to Java, that's not going to be a thing. There's another concept called interfaces, but we don't really cover that here. When we have those mixins, the syntax here, my base class, my subclass or my derived class, inside the parentheses, I put all of the classes that I inherit from. You really want to make sure, though, your core base class is the first one that's listed. And the reason is your interpreter, when it says, oh, okay, I have an instance of subclass here on line 19. I want to call method 1. The interpreter is going to say, okay, do I have a method 1 declared here on subclass? No, I do not. It's going to go to the base class. Say, do I have a method called method 1? I do not. Then it's going to go to mixin class 1. Here's the method. And then it will implement it. There's nothing preventing you from putting method 1 up on your base class. And so that might be more intuitive if you thought about like the string function. So the string function maybe for your parent, you'd want like the coffee machine string function to execute maybe before the mixin one. So just the order in which these methods are called is important. Your core base class, that's the one you want to have first. Okay. So that's enough of the recap. Unit testing, my favorite concept, I guess. Why do we unit test? We want to almost future-proof what we write. So when I write my code, in an ideal world, I want it to live forever. I want to add as much value as I can. But how do I sort of help the people that come after me? They might not know my intent. They might not have seen my documentation. So as I'm writing my code, and some would argue before I write my code, I should be writing my test cases. I should know what my code is going to do. So, I noticed in Project 1, which hopefully I'll get back this weekend, a lot of folks, when they were doing that image manipulation, you kind of just stumbled into something. And that's cool. That's fine. I wanted you to have a little time to explore. But there's a difference between saying, oh, I wrote some code and it did something really cool, versus I intend on putting a circle around the dog and then an X, right? If you went in with that, as your forethought, you could have written the tests for it first and then wrote your code. And then when you found out, like, oh, shoot, it's really difficult for me to do the math to put a circle around my dog, I'll just do the X. Okay, that's cool. But that's different than just, oh my gosh, I kind of inverted the colors and I stumbled into it. So we want to really know what our code is doing and make sure it does that almost in perpetuity. And or when people extend our code, right, they don't break anything. So these are a lot of different reasons here. I'm going to tell you right now, this is going to be a question, a short answer question on the next exam. So I don't know if you screenshot it or remember this slide. I'm going to ask you a question that asks you why should we be doing unit testing, and I'm basically going to expect you to have an understanding of some of these. Okay, so how do we unit test? What does unit test mean? So with respect to code that we talked about today, I've never really used the word unit. What does unit mean to you? A single thing. In the concepts of what we learned, what might a unit be? Functions. Functions are great units to test. How about classes? Classes are a great unit. One might argue if I have an if-else statement, one unit might be the if block, one unit might be the else block, right? So it's open for debate what unit tests could consist of. But typically, and what I'm going to show you here, is we're going to create unit tests for classes that we write. And then we're going to write individual tests for each method or each branch inside of our method that we write. There is a very fun debate, and I guarantee you're going to run into this debate when you go out into industry. How much is enough? I was always of the opinion, and I think it's more so because I was writing a lot of very critical code, that 100% code coverage was necessary. I always made sure I had unit tests for every function, every path, every loop. Other people claim, that's a waste of time. You end up spending more time maintaining your tests than your actual code. I think that's probably a true statement, but I don't think it's a bad use of your time. I think it's a good use of your time to guarantee that this thing works. I've used this example with a lot of people before. One of y'all is going to end up building the next X-ray machine or the next MRI machine. And I don't want my ass in that machine and it breaks, right? Well, how are you going to determine that it's going to break? Hopefully you have unit tests, right? Somebody's going to say, well, wait a minute, we can't release the next version of the software here because we're going to get an overflow or a division by 0 or something. Zybooks introduced this. They had an opportunity, they really missed it, but I'm not sure if people made the connection what these were, even though it says method. So I kind of translated it. Inside Python, there is the unit test module. And if you went inside the unit test module, there is a blank. What is this? What does this represent? It's a class. There is literally a class called test case with, what are these things? Methods. These are the methods, right? And so we can sort of figure out what they do. And then this tells you here, assert equals checks if these two things are equal. Assert not equal checks if they're not equal, and so forth. And they usually come in pairs. Assert is none, assert not none. Assert greater than, assert less than, right? And we'll see how we call and use these functions. If you, and it's not quite literally this, but it's pretty darn close. If you were to look at the implementation of test case, it would look like this without that little mistake here. I don't think test case has a base class, but either here or there. If I was to look at test case, there would be a class test case. It would have some constructor in it, and then it would have each one of these methods. So if you were to look at the assert equals method, it would say, if not first equals second, raise an exception. And we'll get to raise later today when we talk about exceptions. But again, there's no magic to unit tests. You're just using a class that exists in Python called test case with some methods. How do you use that class? You use that class, hint, hint, we're in the inheritance chapter. We're talking about derived classes. You do it by creating a base class. So you're going to have what you know and love today, class my class. You're going to create a class. It's going to have a constructor. It's going to have some methods. In order to test this class, you create another class. And the convention is to give it the prefix test, and then it extends a test case. So again, this is just a class. The class that I want to write to test my class extends test case. Now, again, it might look like magic, but it's really not. Inside this package unit test, or sorry, module, you would find a function. I'm using my language very specifically here. Inside unit test, there would be a function. It's not a method on test case. It just lives out here in the unit test space. When I call that function, Python basically looks for every class that is a child of test case. And then it says, right, I'm going to invoke each one of these methods. And we'll take a look at what the magic is, what you would put in there. But the syntax for you to write a test case is simply, I have a class called product. I'll create a class called test product that subclasses test case. And then I'll write each one of my test methods. This is going to be a critical part to project 3. The assignment, because the assignment's already out there for assignment 10, you don't have the opportunity to play with this in the assignment, but you'll have an opportunity in the lab, and you'll have an opportunity certainly in project 3. Okay, so let's get into this. So, following on that metaphor that we used several times, I have a class called product. It has a constructor, and it has a method called calculate total price. Now, in this implementation, I'm not returning that tuple, just a little bit more simple. I'm taking an optional parameter, include tax, and if the person says, yes, include tax, I'm returning the price times the quantity, times the tax rate, whatever that formula should be. So I may or may not have errors in here. We'll find out. But the first step to figuring out what to test is to just do like a thought exercise. So if I wanted to make sure the constructor in isolation, so the constructor is the unit that I'm referring to right now, what might be some tests that I want to write for my constructor? Yeah. Yeah, I might want to check that. And how many people have done this accidentally? Maybe you've written your code, right? And you put this, you put an empty string here. Maybe you put 0 here. Maybe you put 0 here, right? Well, clearly, because I asked for these parameters in the constructor, I really wanted to say self.name equals name, or self.price equals price, or self.quantity equals quantity, right? So I might want to check that I actually set those values here. All right, so let me just put this back. Okay. So how do I get started testing that? So let's talk just about testing this constructor. So at the end of my class, I'm going to create another class. And this shouldn't be a big surprise what I'm going to call it, right? I'm going to call it class product. And sorry, I want to just bring up my other code here. So I use the same names I did in the solution. So if you take a look at that later, it won't be too different. So I'm going to create product test. I'm going to extend unit test dot test case. So first things first, do I have this module? Let's see. No, let's import it. Import unit test. tests out the product fast. Okay. My code works. Now, I'm going to take this stuff here, because I'm working on my unit test now. I'm going to say unit test.main. So I run this, it says ran 0 tests, no tests ran. Okay, let's write our first test. Def test constructor. The method, so I have to take self. Now, what am I going to do in here? Well, first off, I'm going to say test that the attributes are set from the parameters. Now when I run this, it says 1 test ran. Not a very useful test, but a test nonetheless. So inside here, I'm going to instantiate one of my products. So I look up at my product and I say, okay, it takes a couple of parameters. We just set a couple here. And the names don't have to match, but they might. I'll say this is test product. Let's say my test price is $1 and my test quantity is 10. I'm going to create a product, and our product takes a name, a price, and a quantity. Now, we all know when I do this, right? What does it do? What magic happens at that point? The constructor's called. Like, the flow of control is going to come in here and presumably do this stuff. So I want to test that name is set to the attribute name, price is set to the attribute price, and quantity is set to the attribute quantity. So I'm going to say, whoops, self dot assert equals, oh, and I think did I put that in there? Yeah, I did put that. Okay. Self dot assert equals from my product, check the attribute name. Does that equal name? So I ran 1 test. Let's see, I got some errors here. Product test object has no attributes. Assert equals, did you mean assert equal? Sure. Okay, so I ran my tests. So presumably, we're good. Rinse and repeat. Let's make sure the price equals the price, and let's make sure the quantity equals the quantity. Okay, my test is fine. Imagine it's like 3 years in the future, some new developer comes along and they start making some changes to this class. For whatever reason, they do something like that. I don't know, right? They accidentally do a find and replace. They put something like there. Now when they run the unit tests, it's going to say test fail. Assertion error. Name does not equal test product. So that new person should be able to go like, oh yeah, I made a mistake. Let me just go back and fix that, right? Let me go back and fix it. Most times, the way most sort of institutional development works, when you check your code in, when you sort of certify, hey, my code is ready to go, there's something called a continuous integration, continuous delivery pipeline. Your unit tests are run. For like every code change you make, it runs the unit test. And if your unit test fails, the pipeline stops. It says, hey, human, the code you checked in has an error. Go fix it. And that sort of prevents dodgy code from going out. If you don't have unit tests, there's no way to really prevent that. Okay, so that's a fairly simple test. Let's take a look at something a little bit harder. Calculate total price. Well, what tests might I want to do in here? Nobody?
So greater than anything, or like greater than
What's greater than or less than?
three and both?
Okay, on that theme, I guess I would want to check if I would pass in the value true or include tax, I return the post. If the value was false, I return pre. Those might be two tests I want. Okay. So what does that look like? Well, I'm going to go in here. I'm going to create a test. Indentation is the best. Tests, what's it called? Tests with tax flag is observed. So, I'm going to take this code here. Create my product. And now I'm going to say the actual value I get from P dot calculate total price. It's an optional parameter, so let's not pass one, right? So I should, what does that default to? I want to get the value with tax, right? So what do I expect? So I'm going to say expected equals, and I can do this math in my head, but I want to take the price times the quantity plus, and we can optimize this later if we want, but let's just say I'm going to brute force it. It's price times the quantity plus price times the quantity times the tax rate, which is a class attribute like that. So I want to say assert equal expected equals actual. See what happens here. Got some errors. Let's clean them up. Name assert equal is not defined. Oops, I forgot myself, right? Because it is a method. Okay, that seemed to work fine. So here's a great example of why I might want to do this and sort of duplicate that logic. Again, it's 3 years in the future. Somebody comes along and they did a find and replace in the code. And let's say they accidentally did that. So they set the default to false. I didn't change any of my running code here, but now my unit test is going to fail. Right? Insertion error. 10.6 does not equal 10. Well, this was the formula I expected to be executed when I wanted tax. Didn't show up. So developer gets the warning, developer comes in, changes this back. Depending on how critical this code is, you may decide that you just want to take this and do 2 tests inside one test method. Oops. Where did I put this one? Sorry. I did a bad here. I should have named this test, what did we say this was? The calculate total price. Sorry, I named that dodgy. Okay. So I may want to just put in this other test here, where now I explicitly say false. And here, right, I just expect that. Now, it's not really clear to me necessarily how many tests I have buried in here, but if I want to be explicit, I can pull that out. And then I can say, calculate total price, no tax, and calculate total price with tax. Now it's very clear, you know, if one of these should fail, it'll be very clear to the developer, oh yeah, I screwed up, you know, branch A versus branch B, right? Like somebody comes in here, I don't know, like the post-tax price. I don't know why. They accidentally add 1. if I come in here, right, I should see total price with tax change. The pre-tax one worked fine, but it's this post-tax one that didn't. In project 3, you will be writing test cases for the classes, and you're going to have to write a minimum number of test cases. So if you find yourself struggling to reach that minimum number, consider doing what I just did there. If you're going to test one method and it has a branch in it, candidate for doing 2 separate tests. All right, so if you have not gotten into the unit test chapter in chapter 10, the last one, please get into it. In my opinion, again, this is one of these that discriminates the coders from like the really good computer scientists and developers. Like coder just whacks out code. It may or may not work. They kind of just get it to work. A computer scientist knows what their code does, and they can prove that it will do that in perpetuity. So pay real special attention to that. I think it's very important. I will make that a very critical part of project 3. Okay, we are done with chapter 10. So related, and I'm going to take a breath here, and I'm going to share one of my favorite movies to scope this next topic.
This is great. Oh, beautiful. God.
Sure you know what it's about. Honey, let me tell you.
Where do you think you're going?
With my sound. The sound's critical for this. I don't think it's going to let me share it. Anybody know National Lampoon's Christmas Vacation? One of my favorite movies. If you come to office hours, we'll watch part of it afterwards. But it's basically a scene where everything goes wrong at Christmas.
Oh, beautiful.
Oh, here we go. Oh, here we go. Oh, here we go.
This is great. Oh, beautiful. God.
Sure you know what it's about. Honey, let me tell you.
Where do you think you're going?
I have no idea. We're not going to watch the video. That's not working. So the point I was trying to make with this is that you need to prepare. What can go wrong will go wrong with your code. And unit tests help you detect it, right? But how do you sort of how do you lessen the carnage yourself? And that's this concept of exceptions, right? So the first part of this, there's 2 parts. There's throwing or raising exceptions, and then there's catching or accepting exceptions. So we have this code here, and we've seen code like this before. I have a list, I prompt the user for a grade, and I have a loop. And while the user doesn't hit -1, I'm going to collect the grades in a list, right? And I'm just going to keep a total of them. And then I'm going to ask them again for another grade, and loop, loop, loop. And then at the end, I'm going to calculate the average. So however many grades they gave me, I divide the total by that number. What could go wrong here? You will all experience this 1,000 times. Say that again?
They put a number lower than -1.
They could put a number lower than number 1. I'll challenge you. What happens if they don't put a number in? What if they enter the letter A, right? They think grade meant A, B, C, D, E, F. Well, when I get to that line, line 6, I'm going to try to add a string to an integer. So I'm going to get this type error. Can't add string to int. So how did we fix that in the past? Well, we just put int, right? So it doesn't really help us if the user entered in Actually, I take that back. This one will, even if they enter in -1, this will still cause an error because it's a string, right? So here, now I made it an integer, right? But I could still get that problem, right? If they enter in the word pickles here, for A, now that line's going to blow up, not that line. So I have a second error. So I had a type error, I had a value error, and there's a third one that's sort of hanging out here. This one, if the user immediately entered in -1, how many grades do I have in my list? 0. Can I divide anything by 0? No. So here I'll get a 0 division error. Some people have seen this. I've seen people submit code. This is the basic syntax. So we have a new keyword called try. And the intent here is to say, hey, interpreter, try to execute this code. So all of the code that you've written to date, you would basically indent one level inside a try block. Nothing new there. This is just everything you've done to date. After you write your code, there's another keyword, except. You write more code in here. This code sort of cleans up whatever went wrong here. In a lot of cases, you're just putting a print statement. You're just saying, hey, I caught a division by 0 or exception, or I caught a value exception or something like that. But the beauty of this code is this line here will continue to execute. So I had code, it had a problem, I handled it, and then I can continue on in my program. That previous example, I think I have code for this, we'll see. Our program just ended when we did this crap, right? In like Zybooks, if you do in the lab, your program just ends, it just dies. Well, we don't want that to happen. So, let's see, yeah, I do have a Python tutor here. Let's take this code here, just looked at. So it's waiting for an input here. Like I said, I'm going to put in, well, do something reasonable. Somebody thinks I wanted letter grades. So I put A in here. Does grade equal -1? No, so it goes on. It adds A into my list, nothing wrong there. But there, I get that problem, right? I tried to add a string to the integer 0. That doesn't work. Cool. Okay. So what can I do about that? Well, I can do this. I can say simply, try, and I'm going to take this problematic code here. And I'm going to say except. You might hear me say the word catch. Most other languages say catch there, so I'm going to screw that up. But here, I can say, not adding grade, whatever it was, grade, since it's not a number, something like that. So I'm going to run this code again. Let's do that again. A. I go here, I go here, I go here. Now I'm going to do this call that's going to fail. I'm going to try to add a number and a letter. Okay, error. But my code continues to run into here. Not adding grade since it's not blah, 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 right? Since it's not a number. And my code continues to run. If I want to be ultra paranoid, but it's not as useful, I could put my try like all the way out here. And let's take this out of here. Let's put this back. Like take all that code, put it here, and say accept. If I happen to have some other code out here, critical code that needs to run, I enter in my number. Whoops, I got my error. My accept block goes out here. I still executed that critical code, right? But my program didn't crash. This wasn't very useful though, because I didn't do the try catch in the right spot. So you have to know your own code. You have to know what might screw up and put this stuff in the right places. I'm going to show another example of this, but this isn't the whole story. It's kind of like that journey we had with functions. There's way more code we need to, like, options we need to put in here. So what are these things? Abstractly. Classes, right? This is UML. This is just UML. There is a base class called exception, and Python has all these different exceptions for different purposes. Division by zero, a problem with a floating point, problem with math, name, value, blah, blah, blah. You can write your own error if you need to. You just create a derived class. The convention is to use the word error. I get it, it's a little confusing. We say exceptions, we say error. They're kind of used as synonyms. But the convention is you say these things are errors. So that syntax we just looked at a second ago, you can say, try, put that code, and then the name of the class that you're trying to accept or correct for. In some cases, the way you correct from a value error is going to be different the way you correct for a division by zero error. Maybe you can recover from this, but not that. There are two other things I want to point out here. If you said, hey, it's important for me to catch value error and type error, but what I'm going to do to solve that problem, correct from it, I can batch them together in what looks like a tuple. And I can say, listen, if the exception that's raised or thrown is one of these two, do this block of code. And then it doesn't do the rest of it. If this code raises a zero division error, this will not be executed, but this will. Arguably a bad practice. You can say accept these specific types, accept this specific type, and then accept everything else. This is sort of considered bad form because you're sort of saying as a programmer, I don't know why my code's going to blow up. In some cases, that's fair. Your code is very critical. You don't want it to stop running. So you will have this catch-all bucket. But some people say it's bad form. So these three cases here, if the way I recover from a value error and a type error is the same, I just put them together like that. If value error, type error, zero division error was the same, I put zero division error there as well. If I want to do something specific for one of these exception types, I list the one, and then there's the catch-all. The last thing I promise with this stuff, in these cases where you select either multiple exception types or one, you can say accept this thing as E, and then you have a variable that has some more context. So we'll take a look at that. So here is this same code that we were looking at before, right? So here's this problematic code, and I put a couple of except statements way out here. So if I run this code, okay, I'm going to ask for a grade. So let me put in, there's my little code box here. I guess it put in -1 for me. So, well, grade does not equal -1. Okay, it's -1, so I'm not going to go into that loop. This is going to try to do division by 0. So I fall into that block. Here I caught index error and 0 division error. App cannot app right now due to division by 0. Okay. Let's say, let me put in something not -1. Let's put in 10. I happily add my grade to the list. I happily increment my total, so it's now 10. Next grade, I don't know, let's put in better on this test. You got 100. Ask for a grade again. Let's get out of that loop. -1. Okay. Now, I got past that division by 0 problem. Average of these two grades is a 55. But look at this code I intentionally put in here. The 454th element of grades. Well, I only have 2 things in grades. That's going to blow up. Well, that was an index error, so I fell into this same block. And my code continued on. If I took that out of there, and I said, I'm just going to capture that. Now when I run my code, I will break out of my loop. I'm going to hit that access 454 element again. Now, because I didn't catch index here, it falls into that catch-all bucket. Something unknown happened. All right. So those examples are in here for you to play with. What we'll get to next time is throwing and raising exceptions. I don't want to rush that. That's where you get to say, hey, I have a specific type of error. Where does that leave us? Again, Sunday, project 2 is due. Right after this, I'm going to 454 for 2 hours. If you have questions about project 2, come see me. Wednesday, we will be doing quiz 10. That's on the UML and inheritance, right? Thursday, we will be doing quiz 11 on exceptions. We only have a little bit left on this, so we'll finish that up on Monday. Assignment 10 will be due on Thursday, okay? If you have a chance over the weekend, get into 11 and 12. That's it. We're done. That's the end of the course. When we finish up 12, yeah. All right. See me in office hours if you want to watch some Christmas Vacation. Get that video to work there.
We're in the house. He ain't playing.